Good morning all once again. Let us start today's lecture by having a quick recap of what we discussed in the previous class. Right. So I hope the screen is visible. In the previous class, we started off with a new chapter in this module, the module 3. That is the fourth chapter in module 3, chapter number 10, which is debugging, right? So in this chapter, we initially discussed why we require debugging, right? And we discussed the important aspect of debugging, that is raising exceptions, right? How can we raise an exception? We saw an example of what we have discussed in the module 1, the statements, try and accept statements and how they are useful. Then we saw how to raise an exception using the keyword raise as well as the function exception, followed by the message which has to be prompted to the user, right, or a program. So this was the syntax that we saw, and we saw an example of printing a box, right, an empty box, and creating a or raising an exception for it, right. So we saw exception like width must be greater than 2, and the symbol must be a single character string, right. It cannot be a multiple character. So we checked the length of the symbol also. And then we saw getting the traceback as a string, right? How can we get the traceback as the string? The traceback, we all know when we get an error, we get the data, some information about that particular error, right? So that is nothing but the sequence of the instructions which are executed, the sequence of calls, so which is also called as call stack, right? So we saw an example error, right? So that is nothing but the sequence of the instructions which are executed, the sequence of calls, so which is also called as call stack, right. So we saw an example of the program which we have already discussed in module 2, I guess, the spam and bacon function, right. So we try to raise an exception here, and as you can see in the output that how for the same exception, or for that matter the same error, we got multiple tracebacks saying that we have an error on so and so line, right. So that's how the flow of the program goes. So traceback is nothing but it is the information regarding the error. Then we also saw how to format this traceback using traceback.format exception function, right? We had an example of it. So in order to make use of this traceback.format, we have to import the module for that, that is traceback module, right? And it returns the value which is returned by this traceback.format is the value that will be returned by the function, right, which is right here. So 116 is actually the length of the information which was written in the file that is errorinfo.txt, right, and that length was returned to the right method. Then we also saw second most important aspect of debugging, that is assertions, right? So assertions is a kind of a sanity check, which makes sure that if there is something obviously wrong, right? Are we doing anything which is very obviously wrong? For example, we saw an example of asserting a statement twice, right? We saw an assertion of a statement that is the status of the door open or closed. We checked that status twice, right. So for that we can avoid these things by making use of the assertions, and you also have the facility to disable these assertions in case if you don't need them, right. And how do we disable it? By passing the option that is hyphen 0, which will disable all the assertions. So instead of deleting those assertions, you can simply disable it, so that it will be easier for for future use when you want to revert back to the same program and have the understanding of where all places that you have used the assertions, right. So I think that's where we closed, and in today's section again we'll be discussing about third most important thing of debugging, that is logging. Right, you must have all heard this term logs, logs with respect to the program, right? When you, or maybe logs with respect to when you have studied operating system, right? So the data about the system is getting stored in some file called logs, right? The log files. So similarly, when you run a program, we can debug that particular program by creating logs, right? So the simple way to do is you must have already used while programming, right? For example, when you're executing a program, and you're getting some errors, right? And you're trying to figure out what is this error. You want to understand how every instruction is getting executed, until what point I'm getting the right output and where is it going wrong. So what we usually do, we simply put a print statement there just to check whether everything is okay till that point, right? So simple print statement will let us know that where that value is going wrong for a particular variable, or where the logic is going wrong, right? So basic way to do is by using the printf statement. But how many times are you going to use those print statements? Right? And once you're done debugging your program, then it becomes manually very hectic to go and delete those print statement wherever you have included, right? So for that purpose, we can have another approach, that is the logging, right? So using the logging, we can understand at each step what the program is behaving like, and where is it going wrong in case if there is an error or a bug, right? So for that, we have to import the login module, the import login, as we import all the other modules. The way to do it is same, but as you can see, there is followed by that there is some syntax. So don't worry much about this, but just remember that this is just the basic configuration of logging, right? You can see a basic format, basic structure of how logging can be done, right? For example, the logging.basic config will have these four parameters, that what is the level of the logging. We will understand what is this level and what are the different types of levels, right? But first thing is the level of the logging, what level of logging that you want to achieve. Then second is the format, right? In what format you want to structure this login, right? The logging of uh, the complete program, right? And then for the format, as you can see, there are some other values here, that is the ASC time, the level name, and also the message, right? So we have these three things for the structure of the complete log. Now let me give you an example by making it like using it into a program. Let's say we have this program which computes the factorial, right? We have the program which computes the factorial of a number, and we want to log this program, right? We want to log. Why we want to log? Because we want to check whether at every computation, that is after computation of every factorial, whether the next step is correctly computed or not. Are we getting the exact value that is we are supposed to get or no, right? So just to have that trace, or just to have that step by step analysis of how every variable is changing or updating, then we can make use of this log, right? So the remaining things remain same, that is importing logging, then logging's format, right? Don't forget about this levels and the format. uh, we will understand this in a very short time, right? And then this is just the start of the program, that is logging debug, the start of the program, followed by the function factorial. Now this function factorial is same, which we'll be using usually to compute a factorial, right? Which is a number will be passed as the argument, and we set up a loop in order to compute the factorial. Now, before we start the loop, we set up one login to debug whether everything is fine before we start. And after we compute every value for the factorial, we again set up a login, right, for understanding that every variable is getting updated correctly or not. Right? So once we have these factorials computed, again we are going to check whether the end of the factorial is correct or not. So basically we are trying to put, in the beginning we are debugging, in the middle we are debugging, and again in the end we are debugging using the login facility, right? And once we know everything is okay, we return the total, we compute the, we print the factorial of a particular number, right? So here we are going to compute the factorial of 5, and then again checking whether everything is okay. So logging at the start of the program, logging at the end of the program, logging it in the start of the computation of the factorial, logging it in between the factorial, and logging it in the end of the computation of the vector. Right. So we have now systematic way of debugging, and we can now understand at every point if there is an error or a bug, we can clearly make it out. Right. So let us go ahead and see how the output would look like. Right. So since we have given the parameter for login for the date, the time, right? Uh, so the login module will make sure that the format that you have provided with you will get that in that format. For example, the date of the execution, the time of that particular execution of that particular instruction, right? The length and as well as the level. Now this debug is the level of the debugging that we are doing or the logging that we are doing here, right? So there are different types of level. We'll shortly understand what are the different levels. But one of such level is that is one of such level for logging is debug, right? Which is one of the simplest format or level of debugging. So as you can see, when we debug at the start of the program, right? And we debug at the end of the program. And also we debug at the start of the factorial, we debug at the end of the factorial, and also in between all the steps whenever we compute every factorial value, then we debug at that moment also. So we have now step by step understanding that at each step what exactly is happening and uh, where my program can go wrong. Right. So as you can see there that I is 0, total is 0, I is 1, total is 0, I is 2, total is 0. So as you can see there is some error and you can see that the total is not getting computed. Right. So at the end of it we get the total as 0. Right. So there's an error in this. So how do we compute it? How do we get that? Where is that error? Right. So when we change that for loop that is for I in the range n plus 1, right, uh, to for I in range 1 comma n plus 1, then we can see that there is a difference and the total is getting added to the previous one, right, which was missing in the previous loop. If you can see in the loop, this one for I in range n plus 1, since that value is getting computed and the I only I is getting iterated but the total was remaining 0, we were not getting the factorial, right? So in order to do that we have to give the start value and the end value in the range by giving this instruction instead of just range n plus 1, right? So once you replace that range value here, we can see that we have successfully debugged our program. And now you can see when you execute, you can see not just I value, but the total is also getting updated, right? So when I is 2, total is 2, I is 3, total becomes 6, right? And so on. When I is 5, total becomes 120, which is the actual value of the factorial 5, right? And hence we get the total 120. So this is the easiest way to debug program, though the program was simple, but as and when the programs becomes complicated, the debugging also becomes complicated. So we have different levels for that for logging, right? In order to debug the program using login. Now, what are these issues with respect to prints, right? I told you in the start of the class that using the print after every instruction will not may not be a good choice, right? Of course, you can do it, but the problem with that is once you are done with debugging your complete program, then it becomes a hectic job to identify the those unnecessary print statements and go on deleting those print statements, right? Of course you can comment them, but that too you have to go through those all printf statement which you have incorporated for just for debugging, and then you have to comment them or delete them, whatever, right? So that becomes a little manually hectic job. So that's why using a print statement may not be a good idea, right? So it is not suggested. So talking about the logging levels now, right? So what are these logging levels and what is the use of this logging levels? How do they make our job easier when we try to debug a particular program, right? So the main motive of having this logging levels, different levels in the logs, is to provide you with the uh, way of categorizing, right? Way of categorizing a log message, right? Depending on what is the importance there, what are we actually looking for in that particular program, and how do we want it to be presented in the form of information, right? So information is nothing but the format of logging. So there are different ways to do this logging. One way, as we have already seen, debug, right? So we have used debug in our previous program, that is here. The level of logging that we used was debug. We should, yeah. So in this statement, as you can see, the level is equal to logging dot debug. So that is the level of the logging that we have uh, given uh, here in this case, right? But in case, let's say we want to have a different level depending on the different problems. So how can we get that? So what debug does is logging.debug. It is actually the lowest level of debug. It is the lowest level of logging, which is used for small details, right? Usually you can care about this message only when the diagnosing problems, like we did in the previous example. But let's say you want to have a particular information or record about that login or that error, that bug which is there in the program. So in that case, you need to have a detailed information, detailed record. Then in that case, you can use logging.info, right, which is used to record the information of all the general events, basic general events in that particular program. Or you can also use this logging.info for confirmation, the confirmation of the things which are there in the program, right? So you will have an understanding whether there is a bug or there is not a bug. Then the third way or the third level, these are actually in the increasing order of their level. So debug being the lowest level, slightly more higher level is the info, and then third level is the warning, and we have two more levels. So the logging level, the warning level, the function for the warning level is the logging.warning. And what it does, it is used to indicate the potential problem that doesn't prevent the program, right? That doesn't prevent the program from working, but might do so in the future. For example, you must have already seen in your, any programming lab, whenever you used to do a program a lab, uh, there will be sometimes you'll be getting an error, but there will be sometimes when you'll be getting the output with some warnings, right? So warnings uh, can help you execute the program. They can execute your program successfully, but they might warn you something that the method that you have used or the variable that you have used or the semantics that you have used may not be correct in a longer run, or they might not be correct all the time. So that's just a warning that whatever you have used, it might not be suitable. So instead, prefer using something else, right? So that's a warning, but still you will get an output. So similarly here, we have a level for logging, that is a logging warning, which will not hinder your output. It will give you the output, but it will give you the potential information about the things which can go wrong in the future, right? For example, the variable, if there are duplicacy in the variables and so on. The fourth level in the logging is the error, right? For the logging function for error is logging dot error. So what it does, it is used to record that particular error. If there is an error, it is used to record that error that causes the program to fail to do something, right? So you can get the error if there is an error, right? If there is an error, you can get that information or the record about that error. Then the fifth level of logging is critical. That is, the function for it is logging.critical. And the reason of having this critical is this is the highest level of the logging debugging method, which is used to indicate a very harmful error, right? For example, in error also you can have different types of error. A few errors which might not be harmful for the program, which might not crash the whole system or the complete setup, but there will be few errors which will be very minute, right? So there are types of errors, but there are a category of error which can be very critical, very dangerous from the software point of view, from the program point of view, and it can hinder or damage your complete file. So those errors are categorized in the form of in this critical category, that is logging dot critical method. And as I said, it is the highest level of logging which is used to indicate the fatal error, right? Fatal error that can cause or is about to cause the program to stop running entirely, right? So that falls into the category of debugging level, logging in critical level. Now let us go ahead and understand how do we get these things into the program, right? For example, I think the uh, level logging.debug, we have already seen example with respect to that, right? But just to give you some details, for example, the same thing, when you try to debug it for a particular message, some debugging details, then you can say that this is debug is just for some debugging details. Info is for logging module is working, right? This module is working, so it is an information that the module is working. Warning is that error message is about to be logged, right? This is just a warning, right? And which is the warning that we have given, like this, just for our reference, that this may not be the exact message that you might get from the Python ideally or any language, any tool, but this is just the message for your understanding, right? Logging dot error, which is the error that has occurred, and logging dot critical is the program is unable to recover, right? Which is critical, the program is unable to recover. Right. So having been discussed about the logging, now how do we disable it? Right. Once you have gone through the complete program, you know where is the problem, you have fixed the problem, and you no more want to log the program. Right. You no more want to log anything about the program, errors, debugging, or warnings or anything for that particular program. Then how do we go about disabling? So, like I said, in the printf, if you are making use of the print functions, then you might have to manually delete or comment those print statement. But the reason, of using logging is because it makes the task much more easier compared to print statements by simply disabling these logins, right? You can have just one instruction which can disable the complete login, right? So unlike print, you don't have to go to every statement and delete or comment those logging instructions. Instead, you can just use one command, that is logging dot disable, and you have to just measure the level of disabling, that is logging dot critical, right? So it will disable all the critical loggings, right? So everything is clear so far, or anybody any doubt before we proceed ahead? Yeah. Anybody any doubt with respect to logging? Okay, what about others? Guys, please respond. So let us go ahead and understand how do we log a particular file. Right, we have seen how do we log a particular document, that is a program, a Python program maybe. But how do we log a file? Right, let's say if you want to log a file, then for that, the instructions remain same. That is, you have to import the logging module, logging.basic config. But the thing that differ here is you have to add one more parameter, which is specifies the file name. Right. For example, let's say I have a file called my program log. Right. So I want to log to a file. I have to give the name of the file, right? So my file name is, let's say, my program log.txt, followed by remaining things remain same. That is the level of the logging that I have to achieve. That is debug or critical or error or warning, whatever. Then the format in which I want it, right? So next is the level again and the message, right? So if you have these things, that is, if you want to log into a file, the only instruction that you have to additionally give is the name of that file. That's it, right? So having been discussed about debugging, we discussed about assertions, we discussed about raising exceptions, right, and logging. Then let us go and understand the inbuilt feature that the IDLE has provided with debugging, right? If you have noticed, I don't know how many of you have explored, but we do have a debugger already pre-installed in our Python IDLE. So if you have access to your Python ideally now, you can open your Python ideally and uh, you can perform the same thing which I'm doing here right now. I'm not pretty sure about the mobile version of the Python ideally, whether they have this debugger pre-installed. So anybody who can uh, please confirm that will be good. Right? Those who are using this Python ideally on your mobile phone, they can just let me know whether there is a debugger available for the mobile version application also or not. So let me open the Python ideally, and as you can see here on the above top tabs, we already have a tab called debug, right? So we have a debugger here, and inside that debug tab, you can see there is a debugger. So when you click on that debugger, you will get a window, right? You'll get a window with some controls, that is debugging controls. There are a few variables you can see: stack, locals, source, global, right? So if you want, you can tick it all so that you have the understanding of all the four types of debugging, that is stack, local, source, and globals, right? And as you can see, there are some more disabled buttons here, that is go, step, over, out, quit, right, which are currently disabled because we are not performed anything right now, right? So we have to first select a program, debug it using these buttons, and then we will get some output at the screen, right? But as you can notice here, the moment when I open the debugger, we get a message here that is debug on. So that means the interactive shell, that is the Python ideally shell, it has gone into the debugging mode, and it is not the the typical way of executing the program, and this will be executing the program in the debug mode. So what is debug mode is actually it takes the instruction step by step and it executes very slowly to understand the instruction, whether the instructions given are correct or not. Right? So debugging process is a little slow compared to the normal execution of a program. Right? So even if there is no error in a particular program, but you are trying to execute that program using in a debug mode, then that might take more time compared to the normal execution of program. Right? So anything that we execute now here, any command that you give, it will be considered as a debug. It will be considered by the Python that you are debugging that instruction, and then you are expecting an output, right? So normally, what we do is we simply give the instruction, and if there is an error, we get an error. If it is successfully executed, we straight away within no time, within seconds, we get the output for that. Right? But the debug, when you're trying to execute anything here in the debug mode, it will take a little more time. So let me show you what are the different types of this, what are these different buttons, what are these things. So as I said, when the debug control window appears, select all four of the stack, local, source, and global checkboxes so that the window shows the full set of debug information. So that will give you the information with respect to the bug uh, regarding these all of these values, that is stack, local, source, and globals. Right? yeah, so this is the window that we have seen, and which is called the debug control window. Now, what are these buttons? Let us go and understand what is the task of these little buttons here, right? So, as the name suggests, the names tells you something about the debugging. That is go, something like let's go and start the debugging. A step is step or skip something. Over is again skipping something, some instructions, and stepping over something, an instruction. Skipping few things and executing some other commands. Then out is getting out of this, you know, a particular loop or a debugging step, and then finally quit this debug control. Right. So let us go and understand each one by one. So as the name suggests, the go means the when you click on that go button, it will cause the program to execute that particular instruction, right? Normally until it terminates or reaches a breakpoint, right? So when you have, let's say, step of instructions and you want to execute it in a normal way, you can simply select go. So it will execute the program in a normal way, and it will terminate when we reach the end of the program, right? Or any terminating condition or a breakpoint. Right? We will see what is this breakpoint in a short time. Now step as the name suggests, what it will do is it will execute the next line of the code, right? It will skip the current line. It will execute the next line of the code and then pause again. So it is like a stepwise execution. Well, let's say you have 5 lines of code and you want to have a check of every line, that how every line is getting executed. Then instead of pressing go button, which is the normal execution, all 5 lines getting executed in one time, but in here in the step, every line will be executed and it will stop, right? So when you click on step one, when you go to execute first line, and when you click step, it will only execute the first line and it will stop. So again you have to go to the second line and it will execute the second line and then stop, so on, right? So it is like step into that particular line only, right? Execute that particular line only. So it is the step into function, you can say. Over. Over, as the name suggests, it will execute the next line of the code similar to the step button, but if the next line of the code is a function call, right? For example, let's say you execute one line which is not a function and it gets executed successfully, but if the next line is a function, it will skip that function, right? It will step over the code written for that particular function, and it will execute the other instructions, right? The function code will be executed, you know, it will be executed in a normal way. It will be executed in how we usually execute a program, in a fast way. It will not be executed in a debug mode. So you can imagine that let's say if we have 5 lines of code, 2 lines, first 2 lines are just the instruction, and third line is the function call, right? So when you are executing this 5 line of code using over button, right, using the over, it will execute the first line using debug mode. In the debug mode, it will execute the second line in debug mode. It will execute the function call. It will not skip, but it will not execute in the debug mode. Instead, it will execute in fast way, right? In a usually way, in a normal way. So if there is error in that, we will not be able to detect that. Right? And again, if the fourth line and fifth line are normal instructions, which are non-functional, which are not functions, then those 2 lines will again be executed using in debug mode, right? So that is the use of over button, right? So it is basically like a step over the function, avoids function in debug mode and execute everything else other than function in debug mode. Now the out button, right? So clicking out the out button, what it will do is it will cause the debugger to execute the line of code at full speed. That is the normal way of executing a file. until it returns from the current function. Right? So until it returns from the current function, it will execute everything in the faster way. So it is basically like a step out of the current function call. Right? So if you are into a function call, then out function will execute normally and in a faster way until it returns from that function, the current function that you are into. Right? So step out of the current function call is what out means. And basically quit means it is quitting the entire debug control, right? So complete quitting of the complete debug mode. So this is a simple example of debugging a number adding program, right? A simple number to add is performed here, but we are trying to debug it. So let's say we have print statement that is enter the first number, we input the first, we enter the second, we input the second, we input the third, we enter the third number, and ultimately we find the sum of all these three numbers, first, second, and third. Right. So as you can see, whatever that number is, the sum is the number is 5, the second number is 3, the third number is 42. But the sum that we are getting is 5342. Right? The reason is because, as you can see, that what we are doing is we are trying to concatenate it. Right? We are concatenating it instead of adding those numbers. So it's an error, right? Though there is uh, what I mean is a program will be executed, but the output that will be getting will not be right output. Right? So though there will be no error, but there is a bug. So I hope you know the difference between an error and a bug, right? So though there will not be an error here, you will not get a single error when you execute this program, but there is a bug. Bug means the output is not what it was expected, right? There's an error, right? So when we press F5, that is usually when we execute a program, or when you select run and run module with the debug and then the debugger enabled with all the four checkbox of the window, the debug control checked in, then the program starts in a paused state on line 1, right? So program statement will be like at line 1, maybe here, right? Paused state of line 1. So since it is debug mode, we are into a debug mode, it will be at the line 1 in pause state. And then the debugger will always pause on the neck on the line of the code it is about to execute. Right? Let me show you with an example or here. Right. So for the same program, you can see that now we have this. We have given this bugging adding program here, and we want to debug this program. And once we execute it using a debug program, as you can see here, the main we are getting this main, then module, line 1, print the number. Right. So there's no error till now. That's just the line 1. Right. Now here, when the let me zoom it in more. Now, once you see that the control is paused at line 2, right? And when you click over, right? When you let's say when you click over, the output, as you can see here, line 2 first is input, and here you can see that there are different global, you can say variables that are there and convey some message, right? Also, that might not be much importance here, but you can see that there is no error. Let us move ahead and see, execute the line 7, right? So when I move to line 7 and say print is followed by the concatenation symbol plus, then first, second, and so on to third, as you can see that the output is also getting reflected here. The debug, this is the debug control on the last line, right, which is the 7th line, and the variables are actually set to string, right? The reason is because, as you can see here, let me zoom it in, the first variable, it is 5, though it is 5, but as you can see it is encoded into single quote, which means it is a string, it is no more a number, it is a string. And when we are trying to output it, we are outputting that 5 as a string, not as a number, right? So which is causing the bug here. So now we know that where is that bug, and we can go and fix that by converting into a number instead of a string, and then we can get the correct output. Right. The definition, this is the breakpoint. Breakpoint is usually it can be set on a specific line of a code, which and forces the debugger to pause whenever the program execution reaches that line. So that is defining a breakpoint, right? So when we reach that particular line of instruction, we can say that the debugger can break it from there, right? So there is an associated example with respect to it. Right, so that completes our module 3 and also the chapter 10, right? So if you have any doubts, you can ask the doubts, and I hope you are preparing notes of whatever we are discussing here. Soon you'll be asked to submit the assignments. Yeah, any doubt before closing the session? Anybody, any doubt? Omkar says decrease some speed of teaching. Okay, so these are very basic things, Omkar. That's why I'm rushing these things, because these are very one-liner instructions, which you have to just remember, right? For example, debugging. So how to use this debugging? It's the simple one line of code that will help you use debugging. So there is not much thing to be discussed, but there are a lot of things to be discussed. So since there are a lot of things to be discussed, the explanation for there is not much explanation for everything, every simple concept. So since there is no explanation, or there is no much actual content, we are jumping the guns. We are simply moving on, because there is a lot of more to be discussed, right? A lot of more things to be touched upon. Okay, anybody any other doubt? Give some easy understanding experience other than this. Okay, fine. So we will have an understanding with respect to program. In the next lecture, we will take up a program, and we will use these things in the program to understand it. Yeah, anybody any doubt with respect to what we discussed? Yeah, guys, please reply. Shita says, sir, can you revise module 4 minutes next class? Okay, so we will discuss few programs with respect to the whatever we have discussed in the this module 3, which will cover all the important aspects that we have seen in this module 3. So that will be kind of a revision itself. Anybody, any other doubt? We will have one more session on this module 3 concepts that we have learned using some programs. Okay. uh, Few projects. There are 2 projects also that are remaining, so we will take up that. Okay then. So if there are no doubts, then we shall conclude the lecture. Please complete your assignments, and soon you'll be asked to submit the assignments. Thank you.